What is up, geometry? Due to high demand, I am making this video. I know a lot of you like the sound of my voice. You can't stop listening to me, and you just want me to make these videos. So here I am for chapter 2.6, and you guys are probably already saying, looking at the screen, going, "Mr. Hakes, you have messed up completely. This is all in Spanish. This makes zero sense." I know it's in Spanish. I'm not trying to teach you any Spanish. For whatever reason, my online Big Ideas page doesn't have this problem in English. So I'm going to do this one in Spanish. Okay, I'm not going to speak in Spanish. I'm just going to do this problem. And then I'll bring the rest of the problems over that are in English. Okay, but I wanted to go through this problem with you. 2.6, we are proving geometric relationships. Okay, and we're adding on to proofs. That's really what we're doing. Okay? In this page, it says data, I think, which is given. There you go. There's my Spanish lesson. Oh, wait, there's another one. Deme ustra means prove. Okay, so we're given that AC equals AB plus AB. We have to prove that AB equals BC. All we have to do here is fill out the blanks, okay? So AC equals AB plus AB. Everybody should be getting this one. This one's not too bad. This is our given, which is data in Spanish. So there's B. Now one below it, AB plus BC equals AC. So what is that saying? It's saying AB plus BC equals AC. That's a postulate. Okay. One segment plus another segment equals a full segment. So what do we call that? We call that the segment addition postulate, which is A. Postulado de la suma de segmentos. Look at that, there's Spanish for you. That next step, AB plus AB equals AB plus BC. Okay, well, let's look and what changed here, because we have that arrow, right? What went from this first given to that second one? AC equals AB plus AB. Well, look at it. It says AB plus AB equals AB plus BC. We know that property. That's a transitive property, okay, which is C, I believe. Propiedad transitiva de la igualdad, I don't know, something like that. Yeah, there's C. And then, that last step, what did we do? Well, there's really only one more option, right? We got rid of A, C, and B. Okay. It's substitution property. D. Or subtraction property, sorry. D. And what did we get rid of? We just got rid of an A, B on both sides. We subtracted. Okay, there's your Spanish lesson. Let me bring over the English version now. Oh, there it is. All right, English. I like English. It's one I know. We have to prove in this one that the measure of angle EBA is equal to the measure of angle CBB. And we're given that the measure of angle 1 equals the measure of angle 3. What we have to do is just fill out this flowchart. Right? We have to match each statement with the letters down below. So I'm just going to write in red here what angles we're looking for. Okay, we're trying to prove that this angle in red, EBA, is congruent to CBD. Okay. What's that first statement? Everyone should get that one. That's our given. That's E. Okay? Good. I think we all should get that. No problem. The one below it, the measure of angle EBA equals the measure of angle 2. The measure of angle 2, that's right there, plus the measure of angle 3. Well, two angles added together equals an angle. That would be our angle addition postulate. So I'm going to cross out given. And that's either A or D, either one. Okay, I'm going to say A. How do we get to that next step? The measure of angle EBA equals the measure of angle 2 plus the measure of angle 1. What did we do on that next step? Well, we just substituted 1 for 3. Right? The measure of angle 1 and the measure of angle 3, we just substituted. So we'll say that's C. Right? The only thing that changed was this and this. We substituted measure of angle 1 for measure of angle 3. And we can do that. The reason we can do that is because in our given, look, the measure of angle 1 equals the measure of angle 3. That's the reason we can substitute that. Okay, almost there. Next we have the measure of angle EBA equals the measure of angle 1 plus the measure of angle 2. Okay, what do we do there? Well, that's our commutative property. That's F. That's F. Some of you are wondering, okay, well, what really changed there? What really changed in that next step? Well, what changed was measure of angle 1 plus measure of angle 2. And the prior step was the measure of angle 2 plus the measure of angle 1. Some of you are thinking, that's symmetric. That's the symmetric property, right? Well, let me tell you. Let me tell you what the difference is. Symmetric property. Symmetric, okay? A equals B, B equals A. There's a symmetric property, right? Our commutative property. Commutative property. Commutative, wow. Sorry, bad spelling. Commutative property says A plus B equals C, or B plus A equals C. Notice symmetric. Symmetric, we flip what's on what side of the equal sign. Commutative, we're flipping what's on what side of the addition sign or subtraction sign, right? Not what's on the other side of the equal sign. Please get this in your head. The commutative property is much more used than the symmetric property. And we use the commutative property a lot more. Okay, this step down here on the left, measure of angle 1 plus the measure of angle 2 equals the measure of angle CBD. And we're CBD. CBD is that green angle, right? And we said measure of angle 1 plus measure of angle 2. That again is the angle addition postulate. Okay. And then if we said, right, if we went from this step to this step, we said EBA equals 1 plus 2. 1 plus 2 equals CBD. That means this is our transitive. Okay. Please stay there. Nope. Okay, I'm going to have to erase this whole thing before I move on. Of course. There we go. Alright, moving on. How can you use a flow chart to prove a mathematical statement? Boxes and arrows. In a logical, orderly manner. Okay. You can use boxes and arrows to tell me what comes before what, and to show the flow of the logical statement. Okay. Compare the flowchart proofs above with two column proofs. What's the difference? I'm not going to write this one out. I can read it to you. The flowchart proof, unlike the two column proof, allows you to show explicitly which statement leads to which. Right, so that flowchart just has step 1, step 2, step 3, all in a nice little flow. And two column proofs has a uniform, predictable shape and style. Each statement right below the previous one allows for easy comparison. You guys can see the difference. I'm not going to be too picky on what you guys write there. Let's go down here. In your own words, write the meaning of each vocabulary word. Flowchart proof or flow proof. Okay, I'm just going to write, because this is my words. We have a box, an arrow, a box, an arrow with basically meanings, right? That's what our flowchart proof is. We define each step, but we show it in a nice flowing manner. A paragraph proof is exactly what it sounds like. You write a paragraph on a proof. So it's paragraph proofs. I write a paragraph proving something. And that's what a paragraph proof is. I personally am not a fan of paragraph proofs. I don't like writing in paragraphs. I need more structure. That's just me. You can feel, if you want to write a paragraph proof or a flowchart proof or a 2-column proof on any of your assignments, go for it. I'm okay with it, unless it specifically says we want this type of proof. Okay? Sorry, I have to erase just to scroll down. Theorems and postulates. Right angle congruence theorem. All angles are congruent. Okay, well, all right angles are congruent. Let's start with 2 right angles. And there's a right angle. There's a right angle. We'll say this is 1, this is 2. Those are both right angles, right? We can see that by the little right angle symbol. What are we given? Well, the measure of angle 1 equals the measure of angle 2, right? They're both 90-degree angles, so it has to be given. Nope, sorry. I messed up. Sorry. What are we given? Angle 1 and angle 2 are right angles. Okay? That's what we're given. Angle 1 and angle 2 are right angles. My apologies. Okay, we have to prove that angle 1 is congruent to angle 2. So prove angle 1 is congruent to angle 2. I'm kind of running out of room. That's fine. I'm going to do a 2-column proof, just because we did a flowchart proof earlier. I'm going to do a 2-column proof for this one. Okay. Remove that. No, can't do it. Okay, so here's I'll do it in red. What is my first statement? Well, it's my given statement. Angle 1 and angle 2 are right angles. That is given. What's number 2? How can we prove that angle 1 is congruent to angle 2? Well, we can say the measure of each angle, right? Measure angle 1 equals 90. Measure angle 2 equals 90. Run out of room. I apologize. And that's the definition of a right angle. Second statement. I'm going to go down here. What's number 3? Okay, it's the same proof. I'm just moving down. Number 3. If they're both 90 degrees, what does that mean? Measure angle 1 equals measure angle 2. Why is that? Well, you can say it's just a transitive property, right? If measure of angle 1 equals 90, If 90 equals the measure of angle 2, you can just say, ooh, there's a transitive. Transitive property of equality. Okay? And then that last one, if we have the measurements are equal, well then we can say the angles are equal. Angle 1 is equal to angle 2, well, congruent to angle 2. Okay, which means the definition of congruent angles. For definition of angles. Okay? There's our proof. We had our given. We turn those angles into the measure. So the measure of angle 1 equals 90 degrees, the measure of angle 2 equals 90 degrees. That's the definition of a right angle. We then said the measure of angle 1 is equal to the measure of angle 2. Therefore, angle 1 is congruent to angle 2. Why do we have the measure and why do we just have the angle? Why are we switching that up? And I will explain that right now. In blue, over here. Okay, congruency. Congruency. Congruent means two different things. Size. I'll go down here. And shape. Okay? When it just has angle 1 and angle 2, that's talking about the shape. The shape of those angles. Each angle has the same shape. Okay? Two rays. Okay? One endpoint and two rays. That's the angle, or that's the shape of an angle. Then that's why we have to say the measure of angle 1, because now we're talking about the size. Well, the size of that shape is 90 degrees. And the measure of angle 2, the size of that shape, or size of that angle, is 90 degrees. Then we can say, well, those measurements are equal to each other. 90 is equal to 90. And therefore, those shapes are now congruent. And that's what congruency means. And that's why we have all these steps. This is theorem 2.4, congruent supplements theorem. If two angles are supplementary to the same angle, or two congruent angles, then they are congruent. If angle 1 and angle 2 are supplementary, supplementary means what? 180 degrees. So angle 1 and angle 2 add up to 180 degrees. And angle 3 and angle 2 are supplementary. Then the measure of angle, or then angle 1 is congruent to angle 3. Okay? Your notes for this, all you really have to say is angle 2 never changes size. Oh, I just sneezed, hold on. Oh, okay, it went away. So, if angle 2 never changes size, let's say, there it is, got it out, sweet. If angle 2 never changes size, and angle 1 plus angle 2 is 180 degrees, okay, and angle 3 is supplementary with angle 2, well, angle 2 never changed shape or size. So that angle 3 has to be the same measure as angle 1. Okay, going down. Theorem 2.5, congruent complements theorem. If two angles are complementary to the same angle, or two congruent angles, then they are congruent. So angle 4 and angle 5 are complementary, and angle 6 and angle 5 are complementary, then angle 4 is congruent to angle 6. Same exact concept, just with complementary. Postulate 2.8, linear pair postulate. If two angles form a linear pair, then they're supplementary. Okay, we went over this in class. This should be easy. Angle 1 and angle 2 form a linear pair. So angle 1 and angle 2 are supplementary. Therefore, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay. These two angles make a line, and they have to be supplementary. Vertical angles congruence theorem. What is the vertical angles congruence theorem? Vertical angles are congruent. Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. We know this. We don't have to prove any of these because it's already proven. Okay, these theorems and postulates proved it for us. We don't have to prove these. .6, last one. Oh, last thing at 2.6. Symmetric practice. Complete the flowchart proof, then write the two-column proof. So given angle ACB and angle ACD are supplementary. Angle EGF and angle ACD are supplementary. Okay, so let's just think about that. EGF and ACD are supplementary. Okay. Prove that ACB is congruent to EGF. All right, let's think this through. What is that first step? What is it saying? A measure of angle ACB plus the measure of ACD equals 180 degrees. ACB, I gotta erase this so I can read. There we go. Okay, ACB plus measure of ACD. All right, what is that? That is our linear pair postulate, right? Theorem 2.8, postulate 2.8. Okay, so what we can say here, postulate 2.8. Okay. You could also say linear pair postulate. Okay, so our linear pair postulate. The transitive property. So if the measure of angle ACB plus the measure of angle ACD equals 180, what could be our transitive property? We could say the measure of angle EGF plus the measure of angle ACD equals 180 degrees. Okay. If the measure of angle ACB plus the measure of angle ACD equals 180, we'd say 180 equals EGF plus ACD. Right? There's our transitive property. I'm sorry, I messed that up. I didn't look below. My bad. What's our given property here? Angle EGF and angle ACD are supplementary. I'm just going to write sup. Okay. There's our given statement. This is also a postulate 2.8. Okay. Now, what's our transitive property? I apologize. We can say that the measure of angle ACB plus the measure of angle ACD equals, there's my equal sign, just because I'm running out of room, the measure of angle EGF plus the measure of angle ACD. Okay. How do we get the measure of angle ACB is equal to the measure of angle EGF? Well, we got rid of our ACD. We subtracted. Okay? Then, angle of ACB is congruent to AGF. What is that reason? I want you to think about it. Pause the video. Think about that. What's the definition of congruent angles, right? Definition of congruent angles. Down here, I want you guys to do the 2-column proof. Practice it. See where you get. Okay. Thanks.